looking forward to some Ether dynamics. Go ahead and take it away whenever you feel ready, Alan.
Thank you, sir. So tonight is actually going to be a twofer. I'm going to be doing my introduction to Ether dynamics and presenting a little bit on the dynamic aspect of the Ether movement. And then I asked Mana Stone, our head of quality assurance, to do an analysis on like a more in-depth analysis on what I'm putting forward, and for him to give some feedback and thoughts on how it works mechanistically, and basically just his thoughts on it. So definitely stay tuned for that. So that'll be at the end. But this is going to be, it's going to start with an overview of the history of the Ether and why it was discarded and all that. So we're going to go over some different experiments and such, and some different mechanisms, and then from there we'll get into the dynamics of it. So here we go. So this is an introduction to ether physics, the history as a framework of interpretation, and the physical medium necessary for electromagnetic propagation. So first, all the information that's put here that's cited, you can find all the citations on https search.spaceaudits.net. Thanks to Toby for making all this convenient and easily accessible to everyone. Big shout out to my boy, holding it down on the streets. And if anyone wants the entire library for themselves to import on their Zotero so they can have it offline, etc., you can find the links on my Telegram to download the zip files for the whole database. Just extract it and then import it. It comes with a importation file, so you'll get all this nice, neat organization here that comes with it. All right. So the age-old question: what is the ether? Right, can you put it in a jar? Can you show me a cup of it and all that kind of stuff? We get that a lot. So for me, the ether is the medium that's necessary for electromagnetic propagation. It can be mathematically described as a viscous compressible gas, and we'll get into some hydrodynamic measurements of how light responds when it's in a directed tube, and capable of transmitting energy and radiation, which transmits, and you can feel with your senses, and that's evidence that work has been done and it's carrying that. Then for as physical properties go, we have epsilon and mu, which are the electric permittivity and magnetic permittivity of a vacuum. So those are physical impedance that cannot be removed from a vacuum no matter how hard you try. I think that's the baseline properties of, in terms of physicality. Then we'll get into the dynamic movement of it, which is measured through interferometry. So before we get into all that, we'll do a little analysis and introduction into Galilean relativity and relativity theory, which was put forward to supersede the ether, even though it's based mathematically on the framework of a static ether. So it's, mechanistically, there's no distinction there. So it's all going to fall under the same analysis here. So refresher on Galilean relativity. Suppose you're in a train that's moving at 50 kilometers an hour, and you're walking inside the train at 5 kilometers an hour. Relative to an outside observer, your speed is 55 kilometers an hour. Right? It's just very simple velocity addition. And reference frames, time and space, are absolute. Time passes uniformly for all observers, regardless of their motion, which doesn't lead into any inconsistencies with relativity of simultaneity or twin paradoxes or things like that. And Galilean laws uses Galilean transformations where the laws of mechanics remain the same between inertial reference frames, non-accelerating frames, and they are independent, time is independent of velocity. So unlike relativity theory, where time is a function of velocity, time and space are absolute in Galilean relativity. The speed of light is not accounted for and is assumed to be dependent on the motion of the observer, meaning that it's not a constant, so you will measure it at a proportional delay with or against moving towards the source. And assumes that velocities are additive with no speed limit. So here's what a Galilean transformation looks like. We have x prime equals the x coordinate minus the velocity times time. Y coordinate's the same, z coordinate's the same, and your time coordinate's the same. This is how you would describe a change in position over time based on velocity using a Galilean transformation. Now, for relativity theory, they make use of the Lorentz transformation, where time is defined as a function of your velocity squared over c squared, and the same for time. And the biggest distinction there is that the time between these two coordinates relative to a rest frame is not the same time. They're separate. They're distinctly separate in how it's looked at in relativity for space-time. So if you're in a moving frame, you'll be experiencing a different rate of time, but you won't be able to tell. Everything will appear normal, especially the speed of light. So with that, you won't, with relativity physics, you won't be able to use light to determine your velocity because you'll experience length contraction and time dilation as a function of those. And all that really needs to be said about that. So earlier, when I mentioned that the time in the two frames in relativity theory is different, this is supposed to lead to different physical outcomes. The principle of relativity of simultaneity as a constant, or as a consequence of the constancy of c. So here we have an example here. We have two observers at an intersection point of a balance beam, and we have two balls that are going to be dropped simultaneously. This bar underneath them that's holding them up would be removed at the same instance. They would fall to the balance beam, and it would bounce right back up. There's going to be no deviation because they're both going to hit at the same time. Now, for a moving observer, what relativity would say is that because you're moving towards B, you're going to see that information first, and therefore the simultaneous event is not simultaneous in your moving frame. If we take that same moving observer and we lay out what he would see according to relativity theory, he would see this ball falling first and hitting first, which would cause an uneven deviation in the force applied to the balance beam, which would cause the balls to deflect and go in different directions upon impact. That never happens. There's never been a different physical outcome due to relative velocity. That's a huge contradiction that we'll get into a little bit as we continue on. But this is a different physical outcome is supposed to be a physical consequence of relativity theory, and it's never once been manifested in reality. And secondly, we have invariance versus covariance. So invariance would be a physical quantity being invariant under transformation, meaning it remains the same. And covariance would be a predictable change in the coordinate system that allows for to keep other things invariant. So it's like a secondary, it's like a lesser form of invariance, but it facilitates invariance through the mechanism of change through predictable change during transformation. It's usually done in the descriptions of the coordinate system. So what we were looking at earlier with the relativity theory and that Lorentz transformation, the change in the time, right? So space-time merging two things together, or two concepts that have to change together metrically, because that's Lorentz symmetry. It's what it's all about. So if you need the speed of light to be the same, well, you can use a Lorentz transformation to change your distance axis and your time axis to facilitate the constancy of c. That's a little bit on how there are the distinctions between invariance and covariance. Whereas invariance, you wouldn't have to make any changes to a coordinate system when you're doing the transformation. It would just be, truly invariant. Now we'll read a little bit on relativity theory and covariance, because in the general theory, relativity was expanded to all reference frames using generalized transformations through tensor calculus. So we'll read a little bit here on what that means exactly. It says, let us consider the general claims of general relativity theory. Begin with the myth of covariance. The unambiguous solution to any differential equation is determined, except for the form of the equation, also by specific and/or initial boundary conditions. So those would be like the type of tensors that you're using to describe the interaction between either the conservation laws or the space-time metric itself, where you're changing, or you're talking about curved space-time. You need a flat space-time. You need some differentials of the curved space-time to make a flat space-time, that sort of thing. So those would be how you can change your initial and boundary conditions to facilitate a covariant transformation, which would provide invariance to the speed of light. If they are not specified, then in the general case, the covariance either does not determine anything, or changing a character of the solution can even result in physical nonsense. If, however, The initial and or boundary conditions are specified with the substitution of the solution. We obtain the identities which remained to be identities in any case of the correct transformation. For any solution, it is possible to invent an equation which will be invariant with respect to some specified transformation if we properly interchange the initial and or boundary conditions. Analogies of subspace are often used in general relativity theory. For example, a flat rolled sheet is considered. However, the subspace cannot be considered separately from the space as a whole. For example, when rolling the sheet into a cylinder, researchers usually transfer for convenience into a cylindrical coordinate system. However, this mathematical description does not influence the real three-dimensional space and the shortest distance. So, what we just learned is that your equations don't have to be physically meaningful to give the correct invariant transformation that would give it the appearance of correctness, because the important part of these transformations is the invariant part, not so much the uh, covariance part, because you can just change things around until you get what you need out of it. Previously, we've all heard that the ether is, old science, it's been debunked, et cetera, et cetera. We're going to look at the model of the ether that was put forward at the time of Maxwell and the boys and Michelson, Morley, et cetera. Then that model was discarded in favor of space-time symmetry, which is actually mathematically indistinguishable from the static ether theory. So they somehow kept the ether in the whole time, but just removed the physical aspect of it and just told people that part of it doesn't exist. Whereas we'll be going over a dynamic ether, which provides the physical mechanism for velocity addition in the speed of light, all of these things. We'll take it back to Maxwell's derivation for the speed of light. 1 over the square of epsilon naught times mu naught, which is the electric permittivity and the magnetic permeability. That will give you an induction rate that corresponds to the speed of light. That is what, that's what they used to describe everything. And Maxwell's version of the ether was a static ether, but it would become compressible, and it was the mechanism that facilitated the lines of force for everything, for electricity and magnets and all that. And same with Faraday, he came to a similar conclusion with his experiments with magnets and stuff. So the framework was that there was this medium that was compressible when it was put under stress, and you would get different results for things. So, like for example, Maxwell would describe like a particle deflection interaction between two magnetic poles as the ether being compressed in between them due to the lines of force of the magnet, and that shape that it creates has a little spin to it based on the polarity of the magnet, and that would dictate how that particle is going to be deflected. So that was his understanding of it. And they often represent things as fields in mathematics. They describe things as a field. So it's like, what is a field? Those represent properties or quantities, such as a magnitude in a particular direction in a particular location. So the magnitude and strength of the direction that's going to be traveled in will correspond to the strength of the field. And then there's usually you're in relation to your position in the field, where you're going to be experiencing the strongest or weakest parts of the field, depending on that magnitude. Um, we get into a recent discovery that Bennett pointed out, which we'll watch here in a second. Actually, pull this up. Let Bennett go over it here. There was a recent thing called a vector potential that allows you to describe the divergence, the curl and change, and the rotation and shape of magnetic or electric field by simplifying the calculations using the vector potential and I forget this scalar thing. Anyway, I'm going to play this out for Bennett so we can that real quick. Let him break that down. Changing the scene real quick.
With the ether.
1 second, let me back it up here. On 1.5. All right, here we go, lads.
that the lab frame must be used in order to predict just discovered recently called the vector potential. I identify it with the Æther, which is why I call it the Æther vector potential. A quick review of what vectors are. A vector is something with size and direction. We indicate it with a bold letter. The vector could be representing a line in space, or it could be representing something rotating. The way we tell what's happening, we use the inverted delta operator. We use the nabla. The nabla applied to a vector indicates whether the vector is changing in shape or in space. So this is called a gradient. The nabla plus a dot applied to a vector is called a divergence. That tells you if there is any radial change in the vector. In other words, is it getting bigger or smaller? The notation with the nabla and an X is called a curl. The curl tells you whether there is a change in the rotation of the vector. So this is a way of conveniently telling us, using mathematics, whether a vector is getting bigger or smaller, or whether it's rotating, or whether it's constant, then it would be 0. So the curl finds everything that is rotating. If we apply the divergence, as we do here, then the divergence finds everything that is radially changing. Well, the first one eliminates all expansion, the curl, and the divergence only picks up what's radial. So the two together must calculate 0 for the amount of change. So this is an identity that's always true. For example, in Faraday's law, if you wanted to interpret this, you would say the curl of E indicates that the electric field has what? A rotation. So if the curl of E is not 0, then there must be a change in rotation. And this must equal the time rate of change of the magnetic field B. So this is how you can look at Maxwell's laws and interpret what they actually mean. We know the divergence of B is equal to 0, which means magnetic field lines never end. They always consist of circles or loops.
Yeah, thank you.
Suppose we let the vector B be the curl of some vector A. Now, mainstream picked A as the symbol, but it's interesting because Æther is what it really represents. If B is the curl of A, then the divergence of the curl of A must be 0 because of this identity. If we use the other Maxwell's laws, we find the electric field is the gradient of a scalar potential phi minus the rate of change of A with time. Now, if you use the electric and magnetic fields, there are 6 of them, 3 in space for each one. But if you use the vector potential A, you have only 4. Maxwell's laws, which are expressed as electric and magnetic fields, simplify to only 4 things that are needed if you use an Æther field, an Æther vector potential. And this is more fundamental than E and B because from the vector potential, I can determine what the values of E and B are.
There we go. Thank you, Dr. Bennett.
Wow.
There we have a
So empiricists,
mathematical description that's more fundamentally apt to describe the E and B fields because you can derive them from the vector potential A and the scalar potential gradient. Were you about to say, Shane?
No, I was going to ask exactly that. So I stopped. You got it. I was going to make sure that they had overcomplicated it and added a step to be empiricists and atomists, right?
I think so. All right, so now the age-old question, doth thou earth moveth, my lord? I think someone once said on Reddit or something. And going back to a nice paper from our boy Wilhelm Wien, he wrote in 1898 about the questions concerning the translational movement of the light atoms. So here he goes over a list of experiments that had been conducted prior to Michelson-Morley. And they kept getting a result that didn't correspond to the velocity that they all believed in. Now, following Kepler's laws and Newtonian dynamics as applied to the sky, their model dictates that the Earth must be moving at a certain velocity. And they all had this static ether conceptualization of things. The idea was that the Earth would move through this ether, and then they would get measurements of, they would experience a retardation in light that's traveling perpendicular to that direction, and that it's being dragged by the ether, so to speak, and that would reduce the light proportional to that velocity, and they would be able to measure that. So they had done a series of experiments that we've been over many times, like a truncated list here. Basically, they knew the exact proportional ratios to measure relative velocity using light. So we'll get into what all sparked this. Now, as we, just to look a little different, but an important note from our boy Wilhelm, because he lists all these experiments as negatives for Earth's motion. Gives a quick note on whatever theory would be able to explain this. It should be able to explain the positive results in some of these measurements, such as Fazal, the Aries failure measurement, where they had to tilt the telescope by 0.8 arc seconds instead of the full predicted amount of 15 arc seconds for 6 months, and then back 15 arc seconds in the latter half of the year. And a couple other experiments that we'll go over that gave slight positive results, but not to the magnitude that they were required. So what he's putting forward is he's like, if there's a stationary ether, then you can't explain X, Y, Z about these experiments. But if there's a moving ether, you can explain these, but then it conflicts with these because why isn't there a velocity of Earth, et cetera? So we can start to see that the problem here isn't necessarily that it's an ether problem. It's a Earth velocity problem that we're going to get into. And I think so. There was a Doppler, and I think that was the last of the important results for our boy Wilhelm Wynn, or whatever his name is. So going all the way back to Bradley, so that we can get the context for Aries failure and some other things moving forward. This Bradley had a telescope angled up 90 degrees at his zenith, and to keep starlight in the center of it, he had to pull his telescope forward a little bit to keep that starlight center. What he had, and over the course of a year, what he plotted out was a deviation in 20 arc seconds. And when you ratio that against the speed of light, you get 30 kilometers a second. Everyone was like, oh, no way. This must be confirmation that the Earth doth move, my lord, as they used to say back in the day. And to put the matter, because this is just a measurement, right? This actually can't tell you if the Earth is stationary and the starlight already comes in at that angle due to some drift, or if it's the Earth's velocity that's producing it. To put the matter to experiment, a couple of things were proposed. One, before we get to the proposed experiments to settle that, there was a couple of other things that we're going to go over. So starting with Arago in 1818, he had the hypothesis that he would have to change the focal length of his telescope every 6 months when the Earth is moving with or against the incoming starlight around its orbit. So when it's perihelion and aphelion, he was hypothesizing that he would have to change the focal length based on those parameters. What he found is that he didn't need to adjust it for any reason. So that was one. And then a second experiment that he did was he introduced a crystal prism half covering the incoming starlight. And what he was doing here was, suppose this beam is just one singular beam and not two beams. Just look at it like a single beam collimating at the focal point here. So what he was expecting is that when the starlight was half intersected by the crystal prism, it would deviate by some angle, and it would have to be you'd have to tilt the telescope forward a little bit to correct for that. And the delay produced here, it would slow the light down with respect to the refractive index of the crystal prism. But also, there would be an additional correction necessary due to the velocity of the Earth moving out from under it. And what he found was that the refractive index of a crystal prism is the same as a moving prism. So there was no correction required for any of that. So we'll read E. Whitaker's analysis of it. So Arago submitted the matter to the test of experiment and concluded that incoming light from a star behaves in all cases of reflection and refraction precisely as it would if the star were situated in the place which it appears to occupy in consequence of the aberration. The Earth were at rest. The apparent refraction of a moving prism is equal to the absolute refraction of a fixed prism. So, unfortunate there. And to bring up an the history of interferometry and how they came to determine that they could measure relative motion and get a velocity out of that was Fresnel drag, the hypothesis that the ether was a stationary medium, but it could be dragged by another material medium that moved through it. What they had here was running water at a certain velocity. They had a beam splitter. They had sunlight. It would go through the tubes here that was carrying the water. It would go with and against the flow. Second. All right. Sorry about that. So let's see here. Yeah, they measured 44%. They measured a 44% velocity of the translational speed of the water going with and going against, so 88% total, irrespective of the refractive index. So they were able to start to establish a relationship between velocity and these fringe patterns when the light recombined out of phase. That was in 1851. So moving on now to 1870, we have Kinkerfuse's second experiment where he was using sodium vapor absorption lines to determine whether or not the Earth was in motion.
Yo, is that a real
Apparently he
picture?
was looking- yeah, that's
Wow,
historical
damn.
That is
archive.
so AI, dude.
So the important part here is that he's splitting light into a spectrum and then analyzing that. And based off of the results, he was trying to determine if the Earth was in motion, and that he had a slight result, but not to the magnitude that was predicted. And then again, we have Æther in 1871. This one's freehand, boys, all natural or whatever. So he used an inclined interferometer. So like the setup we saw here with our boy Fresnel drag to test the velocity of the moving water, this was to test stationary water in a tube to see how that would see if they could measure Earth's velocity, because if the Earth is in motion at 30 kilometers a second, the logic was that this water would carry a 30 kilometer a second velocity potential, and they should be able to measure it in the same way they did with the fringes there in the first one from Fresnel. I'm sorry, Fazal, my boy Fizzy. And, this got a not good result either. Didn't give agreement with anything. Then, of course, we have Airy's failure in 1872, which was the follow-up to James Bradley, where, he had the telescope at his 90-degree zenny, and he was looking for, he hypothesized that the reason he had to tilt his telescope was because of the motion of the Earth. Now, following Arago's logic with the half-covered prism, Airy was doing the same thing. So if he had to tilt the telescope when he put the water in it, that would mean that the Earth was the causal mechanism for the change for the displacement. And he found that he only had to tilt the telescope by 0.8 arc seconds, which is well off of the predicted amount for 30 arc seconds, 15 for the first part of the year and 15 back for the other half. So no explanation or no positive results for Earth's velocity with respect to the static ether model. So Airy's geocentric success and heliocentric failure. So a huge conflict with Airy's theory and the static ether model and all these things is that if light was a corpuscle, at this time some people still believed in light as a particle, little corpuscle they called it, or they were moving on to the undulation theory, which was that light was a wave. So if you were an emission theory lad, you would have to say that when the light hits the water, it somehow starts accelerating to compensate for the velocity of Earth, so that there would be no correction necessary, which violates conservation laws, which is an untenable position for them. And for the undulation theory, they would have to say that the static ether inside of the tube, because remember the ether could be dragged by a moving media, right? They found that. So in the same respect though, if water is in a tube stationary, then it should be carrying the 30 kilometers a second velocity. And what they found was, it didn't. So how you would have to explain that as an undulatory lad with a fixed ether is you would have to say that the ether somehow gets dislodged in the telescope and it's bouncing around in the opposite direction of motion. It's carrying the starlight in the opposite direction, directly proportional to the velocity of Earth that would cause the null reading. So this was proposed by Stokes and Fazal, and then later, what's his name? Lorentz came up with an ether theory, which will be the early rendition of link contraction and time dilation. But for now, the best working hypothesis to explain this was the ether was bouncing in the telescope in the opposite direction. Here we have another AI beauty. There was an experiment conducted by gentleman's name, Ecudres. This guy in 1889 did I didn't translate that to English. That's unfortunate. I don't know the title of his experiment, but basically what he was doing was he had an induction coil configuration set up such that using Earth rotation and Earth's assumed velocity through a stationary ether, this was supposed to produce an electric field, or supposed to be some sort of electric generator, and it didn't work at all. Lorentz later said that Earth's own electric field would cancel it out in the first order. So, don't worry, lads. It's it's still moving, even though we're still yet to detect it. So this is a quote from the end of Wilhelm's paper in analysis theory. Says the negative results are incompatible with the assumption of a resting ether. The assumption can only be the hypothesis that the dimensions of solid bodies are changed by the direction through the resting ether, are changed in a proportion of their velocity to compensate for the lengthening of the path of the light path. The assumption of a moving ether would give the possibility that the ether is carried along by the motion of Earth and at rest relative to it. This would explain all negative experiments and how they would justify that. Now, he's talking about with the dimensions changing solid bodies, like that was Lorentz's hypothesis that the Earth traveling through the stationary ether would be compressed by the ether, such that you wouldn't be able to measure any velocity with it because your apparatus would be contracted. So there would be that's how it would compensate for it. So you wouldn't be able to tell. So this is forward here. So this is stemming from the Lorentz's theory, from his ether framework theory, and then the removal of it with Einstein's answer to Michelson-Morley, saying that there's no ether necessary, no need for absolute space or anything like that. We're not going to use Galilean transformations. We're going to use Lorentz transformations. And in doing that, he introduced the principle of relativity of simultaneity, which we covered earlier, which gives you different physical outcomes for events and whatnot. But we're going to read Lorentz's thoughts on that. So it says here, so Lorentz in 1886 set out to formulate a consistent theory of first-order optical phenomenon that contained elements of Stokes and Fresnel's theories. So Stokes and Fresnel's were the lads that came up with, the answer that the ether maybe it bounces around in the telescope and all that. They had some stationary ether theories, and Lorentz was going to incorporate that. And he used Fermat's principle to demonstrate the consistency of a hybrid theory with empirical data accurate to the order of V over C, and concluded briefly everything occurs as if the Earth were at rest relative to the rays. Oops, said that wrong. Briefly, everything occurs as if the Earth were at rest and the relative rays were absolute rays. So the speed of light is constant, but you can't tell because you're going to experience link contraction and time dilation. So for all intents and purposes, it's as if the Earth is at rest. We went on to hypothesize that only stellar aberration and the accompanying optical Doppler effect could reveal Earth's irregular motion relative to the sun. So here he was looking for a Doppler frequency shift that would correspond to 30 kilometers a second, which no one's ever observed. And then he was hinging it on Bradley's observations of stellar aberration to be like the only true representation or the only true way to measure it, because that was something that he couldn't apply link contraction and time dilation to. for some reason. So that would be the only way that you could, or through that deviation in the observations over time would be the only way that you could extrapolate a possible velocity. So here, a couple years later, he writes Einstein in a letter. He says, "Yo, Big Ein, remember that time you talked about a uniformly moving clock completing a circuit at the equator and coming back to a stationary clock, and how they would both be out of sync with one another? Well, let me ask you about this. When speaking about the equivalency of both pictures, this should obviously mean as far as our experience allows. And close the following brackets because I stepped out beyond the bounds of physics. A universal spirit, which without being tied to a specific place, permeates the entire system under consideration, or of which this system is composed and could feel all events directly and would naturally immediately distinguish one of the systems of U and U prime, and that was the stationary clock and the moving clock, et cetera, over others. Although we are no such universal spirits, if we retain the common notion of a spirit or body, surely we are not so vastly different. For according to this view, we must feel material processes occurring in the brain, and since we can only say with certainty that the intellect has the seat of a specific point in the brain, it looks as if we could really perceive what occurs at different locations of our brain. Sufficient powers of discernment. Examine it for directly for simultaneity. What he was saying here was, hey, Big Ein, you know that example that Alan just gave earlier about the balance beam and how no one's ever observed a deviation as a physical outcome that leads to a different temporal existence? Is it possible that there's some underlying medium that permeates everything and is keeping track of all this because the consequence and primary function of the constancy of C isn't manifested in any way that we can certainly tell? But maybe there's some underlying being that's keeping track of all this and doing that.
Well,
And you guys will never guess what Einstein replied.
I was gonna say you probably ask Mrs. Ein if that's how you're gonna do it. She seems to know the answers.
Well, it turns out neither of the Eins knew, and Einstein never replied to this. That's super unfortunate.
Oh, that's the answer. God damn it! You just ducked and covered. Yeah. Okay.
Straight dipped out. Yeah. So I already covered earlier from Michelson-Morley, right? So all those experiments that we talked about earlier with the light spectra readings, the induction coils, the inclined interferometer, the water in the telescope, all these different things producing a null result. Michelson-Morley was supposed to finally settle the matter. And at the beginning of the paper, Michelson gives his recount on the solution to Airy's failure, or so-called failure, when he's talking about how if you believe in undulatory theory, you'd have to say that the ether is carrying in the opposite direction, which is insane. And if you believe in particles, you'd have to believe it gets faster in the water, which is equally insane. Then he goes on to say here at the end of the paper, after going over the 6 kilometer a second measurements, he says the actual displacement was certainly less than the 20th part of this and probably less than a 40th part. But since the displacement is proportional to the square of the velocity, the relative velocity of Earth in the ether is probably less than 1/6 of Earth's orbital velocity and certainly less than 1/4. And what precedes only the orbital motion of the Earth is considered. If this is combined with the motion of the solar system concerning it, or concerning which but little is known with certainty, the results would have to be modified. It is possible that the resultant velocity at the time of the observation was small, although the chances are much against it. This experiment, therefore, will be repeated at intervals of 3 months, and thus uncertainty will be avoided. This is, again, in referencing to the change in velocity that the Earth would experience as it completes its elliptical orbit to be compliant with the laws of Kepler and Newtonian dynamics as applied to the sky. So he's saying maybe we can get some different velocity readings here of different magnitudes that would correspond to where we would be in the position of our orbit. It appears all that precedes reasonably certain that if there be any relative motion between the Earth and the luminiferous ether, it must be small enough entirely to refute Fresnel's exploration of aberration. So this was, what he's saying here is that the way that Fresnel explained and Stokes, how they explained the Aries failure by saying that the light gets carried in the opposite direction. He's saying that the magnitude here was too big to be applied. So when they look at Aries failure, they don't acknowledge the 0.8 of it. They attribute that to they're just like, instrumental error, experimental error, blah blah blah. They don't accept that reading, so they say it's like an actual 0. So they're saying if you take these measurements as is, it would refute that theory. Stokes has given the aberration, which assumes the Earth is at the surface to be at rest with regard to the latter, and only requires addition to the relative velocity and to have a potential. But Lorentz shows that these conditions are incompatible. So the other competing theory was Lorentz contraction. Lorentz contraction and time dilation, which is supposed to give a null reading. So if you take these measurements as is, you can't apply link contraction and time dilation because they would be too big. You don't measure it in your frame. You measure a constancy of C, and you just mathematically derive how much you would have to be contracted to maintain your belief system and the velocity of the Earth. So Stokes and Fresnel assumes that the existence of the potential together with Fresnel's coefficient. Now, if it were legitimate to conclude from the present work, the ether is at rest with regard to the Earth's surface, according to Lorentz, there could be no velocity potential, and his own theory also fails. So here, we just knocked out all of the potential explanations that were given for the previous theories because we have a velocity measurement that is outside of the magnitude of experimental error, and but it's too small to confirm Newtonian dynamics or Kepler's laws. That leads us to the dynamic ether model. I first came across this when I was reading about Galev's work with an interferometer. He kept making references to how his measurements were compliant with the predictions of Atsutovsky's ether model. I was like, "Ooh, what's that? We gotta learn about that." So Atsutovsky's ether model is based on 4 primary effects. There's the anisotropy effect, height effect, and the space effect, and the hydroaerodynamic effect. The anisotropic effect is that there will be a preferred direction in the speed of light that will follow sidereal time. So you'll be able to. Basically, what he's saying is that there will be an east-west bias for electromagnetic propagation and no north-south bias. There will be a height effect. And this is that the velocity measurements will increase as you increase in altitude. This was substantiated by Miller's work when he went to Mount Wilson, 1,800 feet above sea level. And then Galev's work when he did a velocity gradient between, I forget the measurements, but it was I think it was like 900 or 1,300 feet above sea level down to about 150 or something like that. He was using radio reflectors and stuff to establish that gradient that leads up to what Miller measured. Then there will be a space effect. And this is that the ether will have, they call it galactic origins, meaning that it's, coming from the solar system and not just like local to the Earth or something like that. But what he's putting forward here is that there'll be a periodicity in the speed of light that's measured that will fluctuate that fluctuates corresponding to the position of the sun and the stars. So there'll be a sidereal fluctuation and an annual fluctuation that corresponds to the position of the sun. And that was measured by Miller, Galev, Hector Manera, and I think those are all the periodicity lads. Then we have the hydroaerodynamic effect. And this is that light will respond in a hydrodynamic fashion in the same way that gas moving through a tube would do. So we'll get into the specifics of what that means as we go forward. Here we have the hydroaerodynamic effect. Velocity of electromagnetic propagation depends on movement parameters of viscous gas like ether in directing systems, for example, tubes. It is stipulated by the solid's interaction with the ether stream, the material medium, responsible for electromagnetic propagation of waves, as it is known as the laws of fluids and gases in motion. In their interactions with the solids learnt by hydroaerodynamics, this effect apparently should be called etherdynamic effects or etherdynamics effects with reference to etherdynamics. Shout out to our boy Atsutovsky. It can be seen here that the height effect is referred to the work of the ether hydrodynamic class, so that that velocity increase as you go to altitude would correspond to you're getting closer to the source of what's causing the rotation. And however, the work by virtue of methodological reception distinction used for the discovery of the effects indicate as separate. We'll read a little bit on this. So in the case of velocity, in this case, the velocity head of the gas will create a pressure drop at the ends of a pipe under the action which gas will flow, it flows develops in the pipe. Time of the gas flow development in the pipe and the speed of the steady gas flow are determined by the values of the kinematic viscosity of the gas, the geometric dimensions of the pipe, and the velocity of external gas flow. It is important to note that the development of gas flow in the pipe to the steady state value of the flow takes a finite period of time. The displacement of the fringes of the interference pattern relative to the initial position would be observed during the time when a physical vacuum motion is when the physical vacuum motion is established in the tube. In this case, the value of the displacement of the fringes will be proportional to the speed of the external flow of the physical vacuum, i.e., to the value of the anisotropy of the speed of light. And the time that it would return to for the fringes to return to their initial position will be proportional to the value of the kinematic viscosity of the vacuum. The proposed method of measurement and the measured devices are of the first order, since it does not require the light beam to return to its initial position. Let us consider the possibility of their realization. We'll get into what the device he used was, what it looks like. So here he had the setup for the interferometer that's on this tripod here, and it's on a motor that rotates. He can orientate the interferometer from the north-south direction to the east-west direction. What he's going to do here is he's going to use the motor to turn the interferometer from the from north-south to east-west. He's going to be looking for how long it takes for the wave bands to settle and get to where they're coherently readable. Here's what the interferometer looks like without the case over it for the shielding. So here he's got a tube for the direction of flow for the ether to build up in, and then so when it's in the north-south position, there's no pressure difference. It's just completely moving through it. And then when he orientates it east-west, it creates a pressure difference, and this starts to flow through it, and that's going to change the flow from laminar to turbulent. And then when it's in turbulent flow, that's when the wave bands are going to be the most chaotic. And then when it settles and they're not chaotic anymore, that's when he's interpreting that as the viscous gas has gone into it's returned to a laminar flow as it's moving through the directed tube. And based off of Miller's work, different material properties such as dielectric insulators or conductors have different values for how they affect these readings. So they'll affect the ether flow through them in the same way that it would for a gas moving through a tube or a liquid. So here's a cross section of what that would look like in the interferometer. Here we have the flow coming into the interferometer. Then when it's perpendicular to that, there's no pressure difference. Here's a topographical view of the same thing, and then because he has it configured for the detector to recombine without a round trip, it's that's the first order measurement aspect of it. So it's not going to be canceled out by, well, the ether carried it in this direction and then it got retarded proportional, so it gave a null or something like that. So that's not what he's putting forward. So quick notes on laminar and turbulent flow. So if we're looking at smoke here, flowing up in a laminar flow, you see that nice silky look it has to it because it's all flowing together. And then as it gets further away, it becomes turbulent. And that's where we get these swirls where the laminar flow starts to basically interrupt with itself. So there's two reasons this can happen. A velocity change or a physical obstruction will cause laminar flow to go turbulent. You have the when he gets into the equations and stuff that he's using, like what he's just describing here is going to be, flow through a tube. That's really what we're looking at. And then you have a Reynolds number value going to determine the properties for whether you're looking at or when a laminar flow is going to become turbulent. You can predict that based off of the Reynolds number, where V is the velocity of the medium, L is the characteristics of the linear dimension, so like how long the tube is. That X there is the kinematic viscosity of the medium. On that will give you your Reynolds number, and you'll know exactly when you're going from laminar to turbulent. To kind of give a little diagram of what that would look like, you would break this tube down into 3 layers of the flow, where you would have the boundary layer. So this would be like the edge kind of closest to the edge of the actual material. You would have the the transitional layer, which is a boundary layer defined in between the initial boundary layer and the part where it becomes the turbulent boundary layer. We're going to start experiencing that turbulent flow due to a velocity change. Okay, and then the other part of this is what's called a Fermi surface. So earlier I was talking about how Miller did experiments with different shieldings and found that interfered with the readings. So what a Fermi surface is, you can kind of think of that like when in any material there's like you could say it's like a band of electrons that's in the where they would be most densely concentrated, and that would affect the conductivity of the material. And you can think of that like this green area here would be the band of electrons where it's most dense in this material here. And this material could be anything, doesn't matter, just for visualization. And then this pink area here would be the conductivity of the material and like how conductive it is based off of that Fermi surface value. So if this was like metal and you cooled it and the electron layer became thinner, as this green would start to dissipate, it would get, the pink would expand, so it would be more conductive. So that's kind of baseline of how that works. All right, and then when you get into flow through a medium, you get into the Zoli parabolic velocity profile. This is describing that the center position in the middle of the tube will be where the velocity is the fastest, and as you get closest to the edges, that's where you're going to experience, friction and all that in the flow. So when we look at this, our maximum velocity will be here in the center. And then as you get closer to these walls, that's where you're going to experience friction and whatnot. And those are going to dictate, the turbulent and laminar flow properties based off of the viscosity and how it's responding to that material, as if it were a gas like any other material gas. Here again is just another cross section of what that looks like and what the equations are describing there with the flow and the velocity. And then that segues into Atutovsky's Æther parameters, which we'll be going into in future presentations. But Galev was saying that his kinematic viscosity derivations from his experiments coincided with Atutovsky's estimation here, where the kinematic viscosity 4 times 10 to the 9 meters per second. And we get into I think that's about it. Oh yeah, sorry. So this was in relation to the vacuum properties earlier that we talked about, electric permittivity and the magnetic permeability. So what Atutovsky does in his Æther model is he turns the permittivity into a pressure gradient, and he turns the permeability into the density of the Æther. So if we look at the Æther as that gas flowing through a tube, it would have these properties as derived from Atutovsky, where he's turning that into a pressure gradient, and the density to give it, volume and all that. And that's about all. That's about all I have on that so far. So, any questions, comments, concerns?
Yeah, I'd like another visual demonstration of turbulent versus laminar flow. Could you find a silkier smoke to demonstrate it in?
No,
No, that's the best we could do. I had
What's the
had no
most
idea how to
possible?
visualize it. And so you showed that, I was like, oh.
You could look
So I got a
at
question.
Also, did you draw
what's
those?
up, man. Some of them, yeah.
When you were talking about their explanation that the ether could take it in the opposite direction of motion, wouldn't that have caused a bigger aberration?
No, it would have canceled it out. So when they say that it was carried in the opposite direction of motion, when they put water in the telescope, they were expecting to still tilt it. Because they didn't have to, they needed to come up with a reason as to why. So the only thing that they could come up with was that the ether was carrying it in the opposite direction to the same magnitude of Earth's velocity. So it was canceling it out to give them like a null.
All right, maybe it's the way I'm thinking about it, because I'm thinking if the telescope, because the Earth is supposed to be moving.
It's
If the
very
telescope-
retarded. In case you were trying to hard to grasp it, it is very retarded. Like that is, yeah. All right.
So am I retarded or is it retarded?
But no, yeah,
I don't
it
get
is
it.
very, yeah, it is retarded. What I'm trying to say, like you're trying to wrap your head around it, but yeah, I assume you're imagining it correctly.
Yeah, well, I mean, I just imagine the telescope moving because of the Earth, so it would deviate from center away from the direction of movement. So to me, when you say that the ether is moving it in the opposite direction of motion, it seems like it would make it deviate even farther, where it would make more sense if the ether was pushing it in the direction of motion, causing it to stay where it should be, where it would. I don't know.
Yeah,
It just
you got
confused
it
me.
backwards.
Yeah,
Yeah, you got it backwards. So water-filled telescope, if the Earth is moving, you have to tilt it forward. They filled the telescope and they didn't have to tilt it. But to explain that, they said that there must be something carrying the light in the opposite direction of the motion. It doesn't make sense because there's no like it's just ad hoc it's just ad hoc DS.
they're trying to keep Earth motion and ether some weird way. That's what that is, right?
Yep.
So it never
That's
occurred
exactly
to
what
them
it is.
that the ether was moving and not the Earth.
An untenable position for them because then they would have to concede to geocentrism. And they were all about the Copernican principle. And to make the Earth not significant and special, you just simply put it in motion. So their diehard core fundamental belief is that the Earth is in motion. And if they were to start to interpret things through that lens, it would lose explanatory power over the sky. Because once you
Damn.
don't have a constancy of c, you can't use c. You can't say stellar aberration is due to the Earth's velocity, because it could be due to anything at that point.
So like they're trying to take the empirical results that they got and mash it together with this belief, and that's the result that you're trying to explain right now, Ken. The interpretive result was that dog shit. So,
well, all right. So that table where he shows what the almanac says, and then I think it was like his actual measurement as he made it, and then there was some difference between them. You know what I'm talking about? For the fall and the spring measurement, there was two tables.
Yep.
And so can you explain to me briefly what each one of those represent? Because there's
Yeah.
he's got a column all the way to the right that shows a difference, right? And I just I feel like maybe I understand it, but maybe I really don't.
Yeah. So when you're moving towards the Earth, he was thinking he would have to tilt the telescope forward, compensate for it. And then when you're moving away, like when you're aphelion and perihelion, he would have to start tilting it back. So it was 30 arc seconds in total over the course of a year, and 15 arc seconds for the first part of the year, and then 15 arc seconds for the next half. But in the reverse direction. But what he found was he only had to move it 8 arc seconds.
All right, so the columns there, does one of them represent what he thought he would have to do and the difference that it would make on the right? That's what I'm not getting. There's like, from the right, there's 3 columns. Like, well, if you go from the left, you got, I can't see this column. I can't read any of them, but like these, just go from the right column, 1, 2, 3, the third column. That's like the almanac reading, I think.
No, those are his measure. Well, those are where the star is supposed to be. Star's
Right.
declination in the almanac, so where it's supposed to be. And
Yeah.
then the difference in geographic latitude instrument, correction for the aberration adopted in the almanac.
Okay, so the correct, that's just, what is that? The almanac saying it's here, but due to his latitude, that's the actual position or something for him? And then the difference
No idea.
between the two? Oh, I was just trying to understand those columns because I really didn't understand them. The only thing I ever really paid attention to was the difference between the top, the 51 degrees, 28 minutes, 34.4 seconds, and the 51, 28, 33.6. Those are the only ones I ever paid attention to, and I really didn't understand what that table was trying.
These are his measurements. So that's the total of his measurements for the corrections that he had to make.
Yeah.
When you total these up.
Right, but like February and August, right? And like one season, wait 6 months, then the bottom is another season, and then that's why I say get the difference. Right? Just so we're clear.
Okay. All right. Well, that straightens it out a little bit. I was just that opposite direction though. That just threw me for a freaking loop. I was like, "What?"
Yeah, like the circling around them, right? So they know it goes one way and then the other way. So that's what the 6-month disparity is for. They tried to time it, and that's why he's saying the disparity should be right because of that motion.
Yeah, I got it. So 15 one way and then 15 the other way.
Yep.
For a total
they carried in
difference
the
of 30.
opposite. Right. And the carried in the opposite direction of motion doesn't physically mean anything. It's just retarded. It's only presented as an explanation as to why you don't have to tilt it.
Yeah, I have this rule where I don't try super hard to understand their retarded explanations for the things that they try to correspond to. But that's just me, right?
Yeah, it's not a real mechanism. Like, it's not a real thing that's supposed to make sense.
I admire your
Retarded
effort,
on the
though,
face.
Kemba. Like, honestly, I admire it. Like, I applaud it.
I have a question. If my audio isn't horrible, is the audio decent?
Yes.
You're good, man.
Yeah. So how many ad hoc explanations? Like, do you guys think it reaches a tipping point? Because I think I'm up to like maybe 10, maybe 15. At what point, maybe 100? What point does it become like so ridiculous that they just start from the ground up and reevaluate some of these observations and experiments?
Wow, it got awful the second you started talking.
Yeah, and the answer is never. We're looking at men that are adherent to a certain philosophy, and any deviation from it gets you expelled from the gang. So
And don't forget the same group of people manufacturing their own data over at LIGO, as Toby points out, with starts from noise and then built up through iterative neural networks to get based on an algorithmic template what they want. And it's like, boom, all the data we wanted, just like we said, right? These are the same people.
Oh, no.
High five, boys. Yeah, that was crazy. Not the Lego shit.
Yeah, these are the same people manufacturing the data they want right where they're looking for it. So
that was probably the most ridiculous thing ever, but I digress. Go ahead, Alan. Finish out the presentation, brother.
No, that's it. We're just doing Q&A, and then Stone's going to take over, do his analysis and quality assurance check.
nice.
Nice QA. I love it.
We should get his emoji a sash or something. On Discord.
Sash?
Yeah, like so across his avatar should be like a sash QC department or something. I'm sure we can arrange it.
I don't understand the reference.
You know, like at a
Alright,
beauty
well-
pageant, they all wear a sash, label who they are.
I was
Yeah.
thinking Hall Patrol, but I guess beauty pageant sounds like
Oh, I got you. Like a crossing guard. Okay.
yes,
I
yeah,
got
yeah.
you. I got you. Cool. All right. Well, if there's no further questions or anything like that, we can kick it off with Stone's analysis. Stone, did you want me to bring up the doc for you and then you just run it down?
Yeah, we just sent you one there on Telegram, and you can, just fire to page one there. We're not going to need to see that for a couple of minutes, but that's a good place to leave it for now.
Oh,
And keep in mind, for everything that I'm saying here when I'm quoting the Gallup paper, like I said, I'm shortening them. I'm changing some commas to make it a little clearer to pull in exactly what he appears that he's trying to say. Tonight is kind of reminding me of, or at least striking similarities to a State of the Union address, U.S. presidential style, where the president gets up in front of Congress and everybody in the public and says how everything's going this way, and then everybody clears out of the room. Everybody's done, but the media tune into this other guy who's part of the opposition, and they reflect on what the president just said. And this kind of reminds me of that in a strange kind of way. But anyways, let's bug to it. What I thought Ellen was going to cover a little bit more of was the Gallup paper. And the title of that is Measuring Ether Drift Velocity, let me get that, and Kinematic Ether Viscosity within Optical Wavesband. Again, the measuring of ether drift velocity and kinematic ether viscosity within optical waves band. Okay, now that's Gallup, and that's 2002. And I spent a lot of time on that paper because I think it's very appropriate to just about everything that Alan just laid down. And I will preface by saying that I'm pretty sure that more than just a few of you have noticed that I have not spoken on this topic at all to this little community here, mostly because I don't think that enough attention has been paid to the necessity to objectively weigh the assertions regarding attribution of cause when it comes to the measurement of the azimuthal variation of the speed of light. I would like to thank Alan publicly for showing concern over my hesitation, in that he believes that no one should feel forced to abstain from the conversation out of fear of the opinions of others about what might be said. His stance is a most noble one in insisting that everyone should be heard and their thoughts objectively considered, with ego and preconceived notions cast aside. And I do understand the need to prove the relativists incorrect in their assertions regarding light isotropy and the supporting mathematical premises they draw. And I agree with that necessity. It does seem quite clear to me that they, the gatekeepers, are earnestly trying to obfuscate the truth regarding the causal factors behind anisotropic measurements, which have been consistently made over the past century and some, along with the real-world implications of those same measurements. However, I don't think that this style of interferometric measurement amounts to the key to their undoing. In terms of causal attribution, I just don't see it as something so cut and dry as the picture this gang would like to paint. I see considerable difference between what is commonly referred to as ether and what people like Eric Dollard call counter space. Now, in Gallup's paper, in his experimentation, I don't see correctness in the assertion that ether per se is involved in the actual mechanics behind the creation of light. Let me check. Can you guys hear me okay? Am I still on?
Yep.
Everybody
Your
reading loud and
audio is
clear?
super
Good.
solid, but
Excellent.
it sounds like somebody's snoring in the background. I don't
Thank
know.
you.
Oh,
All right,
that's
that
my
was
wife.
great.
No, you're going to hear more of that.
Okay, no worries.
A
Let me
train
check it
can
out.
be going by, and my wife will continue to sleep through it. In fact, years ago, I took her to we went to many different live concerts. At the Coliseum, at the Stadium in Vancouver. I distinctly remember one time in the Coliseum, which is a hockey rink they used to use for the NHL, for the Vancouver Canucks, that just in the seats, you got 17,000 people. And then there's all the people on the floor on top of that, with the end cut off. So it's probably still about 17,000 people in there. Motley Crue were just going at it at the time with full-on pyrotechnical presentation, almost as good as Nickelback. But about 35, 45 minutes into their set, I look over and there's my wife fast asleep. And it is like ear-splitting loud in there. And she's out. So yeah, be prepared to hear a little more snoring. It's not personal. It's just the way she lives her life. She just is able to completely just turn it off. It's just amazing. And frankly, I'm jealous. Anyways, back to the story. When we're talking about Gallup's experimentation in the paper that I just cited, which is what I'm reviewing here in the quotes you see on page 1 there that Alan is showing, I don't see the correctness in the assertion that Æther per se is involved in the actual mechanics behind the creation of light. And that is an expression that Gallup uses multiple times in this paper. I see light propagation more of an inductive process, which involves the oscillatory perturbation of counter space through the modulation of charge. As it is with free space, counter space is also ubiquitous. So again, here tonight, we are only talking about what I believe, okay? And that's fine if you disagree. But I think that in order to fully justify and validate your disagreement, or any that you may have, you will need to take into account the points that I'm making here. So for me, it all starts in the first paragraph of the Gallup paper. And I think by the end of what I'm talking about here, you will probably agree that my review also of the citations of Atsukovsky's work is not subsequently necessary. So starting on page 1 of my PDF, which you're looking at there, the first quote is, "The results of systematic measurements do not contradict the original hypothesis statements and can be considered as experimental imagination confirmation of the ether existence in nature as the material medium." This is a loaded little sentence. And in these kinds of publications, these papers, wording is key. I've actually said it many times, but not very loudly, and some of you may recall those instances. I will assert that care must be taken to avoid assumption about the assertions being made and their extent. The wordings in this paragraph are frequently used throughout the paper, and there's a reason for this which appears to me to be overlooked. Now, I could take a very glib approach to Gallup's use of the word imagination and cite it as sole reason to disregard any conclusion drawn anywhere in the paper, but instead I will suggest that there is a shortcoming in the translation process to the extent where the word hypothesis should maybe have instead been used. Even the word intuition might fit better than the word imagination. And he does also use, in fairness, he does also use the word hypothesis 18 times in this same paper, as opposed to 10 times for imagination. So from this point forward, I will continue to quote his use of the word imagination, but you may all assume that I'm in agreement in each case, that the word hypothesis could instead have been used. And there really isn't much of a difference in their grammatical function. but I do agree, concede, suggest that the word hypothesis is more appropriate to the scientific process in general. Back to the page you're looking at in the same paragraph, the optical measuring method of the ether movement velocity and the ether kinematic viscosity has been proposed and realized. Skip to adding to that what he says on page 4, the imagination of the hydroaerodynamic and I guess ether dynamic effect existence is accepted as the initial position. So I guess he's saying this is the initial premise of this paper, and he's accepting this and working on that presupposition. Not sure how clearer the language appears to you, but to me this translates to something along the lines of, let us temporarily suspend disbelief for the purposes of analysis in this paper. And this is another implication that ether is a kind of pseudo-physical matter and moves according to the laws of fluid dynamics. His assertion is that ether is physical, while at no time in this paper providing any direct measurement of it. These terms imply that ether, in the paper, he is implying rather, that ether is matter through which light propagates, also moving through free space, and possesses physical properties, which are typically used in description of physical matter, which can be measured directly in a variety of physical ways, which don't involve the indirect measurement of something like the modification of light propagation characteristics, like in interferometry, I should say. Okay, back to page 1 for the next quote. The experimental hypothesis verification of the ether existence in nature, i.e. material medium, responsible for electromagnetic waves propagation, has been performed earlier in the works, and he quotes the works. I think this is an error in causal attribution. Ether is being painted here as a matter-based substance through which light is propagating, and that light propagates because of the existence of Æther, even implying that light may not even be able to propagate without its presence as a part of the process. Now, I'm not really hard on that point, but it appears to me that's what he's trying to say through the language that he's using. So for clarification, I see his use of the word viscous to mean a high resistance to flow, or in this case, resistance to propagation of light itself. And he's using the term incompressible, not compressible. He's using the term incompressible many times to describe a quality of physical matter, like water, for example, which is incompressible. Yet he is also asserting that ether possesses certain properties of gas. The bigger point here is that no effort is being made to distinguish between matter and energy. That they're two, those modalities are completely different in nature. So quite the opposite, apparently. He seems to be borrowing from both worlds. And I recently watched some videos by a guy named Eric Reiter, R-E-I-T-E-R, Eric Reiter. Did a couple about quantum mechanics and wave-particle duality and the whole issue. And I think he made a very astute and often overlooked statement. He stated that when it comes to identifying the difference between matter and energy, one must comprehend that by basic definition, matter requires energy to accelerate it. Conversely, light energy, or EM, at the very beginning of its propagation, already naturally travels at a rate of roughly c. So I'm hoping you can see the difference between the two, between matter and energy. So Gallups' use of the expression physical fields, I'm hearing him implying more of the same. I think it's incorrect to assert that something physical, like matter, is, quote, responsible for EM wave propagation. Back to page 10 with the quotes. Let's see, everybody happy over here? Take a look at you guys. Oh, Alan is on the ball. Very good. Page 10. At procedure implementation described above, it was marked, as in noticed, that at the whole time course of value D, variations corresponded to variations that did not contradict the original imaginations about the interferometer work. Again, Galev repeatedly makes use of the expression did not contradict. Now, to me, this sounds similar to a hypothetical murder trial where the jury comes back with a verdict to the effect of, we, the jury, are not able to find that the accused is not guilty. That is to say, we have not seen enough requisite evidence to convict, nor have we seen enough evidence to acquit. And going back to the page in front of you, this is another example of the same. Also, again, like I said at the top, I'm revising these a little bit for clarity. The tests and analysis give the basis to consider that the hydrodynamic description of the interferometer operating principle is adequate to the imaginations about viscous ether stream in tubes. And the interferometer is suitable for drift velocity and kinematic viscosity measurement. Again, I'm thinking here that language is the key to understanding what he's saying in this paper and what he's not saying. This is regarded as a basis to consider that the term hydrodynamic applies in making an hypothesis about the appropriateness of application of tubular viscosity formulae to Æther analysis. Then there is the matter of the measurements themselves. So we have to take a look at the location, and this would be about page 2, Alan. Go to the map. That's the puppy right there. 13 kilometers north of Kharkov, over on the right there. We're talking about 2 open-air sites, 15 meters apart. They were constructed out in the countryside at about 200 meters above sea level, each of them situated at 1.6 and 4.75 meters above the ground. Site 1 was shaded by trees, and the second, it was arranged with an umbrella for shade to keep it out of direct sunlight. So Site 3 that Galev used elsewhere was upstairs inside a brick building, 30 meters above the ground at 130 meters above sea level. Excuse me. His testing involved between 2 and 4 cycles of readings per month, taking measurements for 25 or 26 hours at a stretch, 5 to 7 measurements taken over a spread of 10 minutes at the top of each hour. And those 5 to 7 measurements were averaged into a single recorded value. So 6 times 25 hours equals 150 measurements per cycle / day, if you will. If in all some 2,300 measurements were taken, we're only talking about 15 days worth of measurements over a span of 6 months. And that comes to around 8% of that entire length of time where he's actually sampling. So for me, this brings up the issue of decisions made regarding adequate sample resolution. As well, we see no mention of something as elementary as moon phase, for example. When attempting to validate a scientific hypothesis, this seems far from complete. And I guess that I may have slightly higher standards than some other members in the scientific community to no end. It doesn't matter. It's just an observation. Again, what I believe. Okay, back to the quote page. Near the end of page 15, it says, "It can be supposed that the ether stream breaking by the house walls, as in this brick house wall, was the reason for the ether drift velocity smaller value measured in the experiment," and that would be number 10, site 3, in comparison with the experiment results 7 through 9. He uses the term ether stream breaking. This adds to my assertion that what we call ether is an energy-based field, which attenuates as it meets up with solid matter. This aspect serves to invalidate all assertions that ether is a material medium, which is, quote, responsible for EM propagation and possesses properties of a viscous gas. If it were such a thing, it logically suggests that the ether would be completely stopped by brick walls, and that light would not propagate at all inside the building in areas where it is absent. Back to the quotes page. In the fifth last paragraph of the paper, he concludes, again, I've shortened this, on page 22. Hence, the results do not contradict experiment results and imaginations of the works about the northern position of the ether drift apex that demonstrate the reproduced result nature of the ether drift effects measurement. I take this to mean that he's asserting that he reproduced the conditions of those who came before him, and he measured nothing contradictory. Again, we cannot return a verdict of not guilty, to me, is what I hear him saying. And I think it's also important, for sake of proper geometrical framing, to look at the Kharkov location in terms of latitude with respect to the drift apex, of the orientation of what he refers to as polar rotational center of imagined movement of the ether. So if you go back to the map on my page 2, you can see Kharkov is roughly at 50 degrees north. And from that point, he identifies the drift apex with a direct ascension of 17 and a half hours and a declination of positive 65 degrees. But how many people, how many people can quickly mentally visualize this coordinate in terms of free space? Not many, I'm thinking, other than solid astronomers. Anyways, this translates, for the benefit of the rest of you, to an azimuthal reading of 262.5 degrees, which is 7.5 degrees south of due west from his location, at 65 degrees up above his horizon. Like a wind direction vector, the heading represents the direction from which it is arriving. Face that direction and it'll be hitting you smack in the face from 65 degrees above your horizon. And he agrees with other observations which show an increase in what he calls ether movement velocity with increase in height above the ground. However, one must come to grips with the fact that these measurements are being taken no more than a couple of hundred meters above sea level. No measurements have been taken across the full thickness of our air mass layer, let alone in, quote, space. Not that there is such a thing. So we can only guess about how that gradient actually looks so far above ground. There is one other commonly observed phenomenon which parallels this kind of observation for me, and that is the ambient electrostatic gradient. You know, the thing that's in Feynman's textbook that everybody quotes. You know, this is the thing that's causing lightning, and we associate it with gravity cause and that kind of thing. Yet he addresses this simple fact at no point in this paper. To say the least, his data sample set is greatly lacking in altitudinal spread. Instead, he then dives into the formulae related to fluid mechanics of a typical cylindrical pipe or tube. So Ellen, if you bug down to my page 3 in the PDF, you'll see that I've modified figure 1 a little bit. This is one that you used in your presentation as well. And I've substituted the variables with their related terms, along with providing the 65-degree angle at which the incoming ether force will be coming, per the mentioned declination that I just covered. I think he should have also drawn the arrow inside the pipe slightly shorter than he did the component arrow outside the tube. That would agree with the premise of his chosen formulae. This is the inherent geometrical association that he's attempting to draw with this paper, that the incoming incident ether vector will hit the opening of the pipe at an oblique angle, and the horizontal component of that vector will govern its velocity through the tube. Change the angle of the tube, change the drift velocity through the tube. Now, this is something that I I can't stress enough, a simple logical proof that there is no material component in this scenario is that when the axis of the pipe is oriented in any way other than completely parallel and fully aligned with the ether initial force, the oblique incident angle never causes the pipe to move. Nor is any heat created in the collision/interaction between the two. No physical friction exists between them. And I can't stress that enough, that this is really simple, logical proof that this analysis is not so cut and dry. Back to the quotes page on page 1, Ellen. Rather, other direction. Please go to my page 4. Sorry about that. And you'll see figure 3.
Page.
Again, my page 4. You'll see figure 3.
Oh.
Where you're looking at the interferometer. Again, slightly modified. In the center, you can see that I've got a circle around the A sub I. That is actually the horizontal rotation of the entire machine, the entire instrument, with respect to the vertical axis. So in figure 3, he then takes that geometric relation to the actual interferometer, showing the incident angle coming in from the right side. But this is a top view, so we don't see the interaction of the angle of declination come into play in this image. He has only drawn the horizontal component of that initial vector. In a top view, the declination would represent oriented at 65 degrees downward into the page as it travels from right to left across the image. Personally, I don't see this experiment as any kind of concrete confirmation as to the cause of the measurement spreads that they're making. So down onto page 5, Ellen, I hope now that you can easily see how the same anisotropic results could be achieved in an elementary analysis of Earth's commonly observed electrostatic gradient, which within itself exists a polarity combined with the polar influence of the magnetic ambient field, the strength and planar orientation of which we've always been able to measure with a simple 2D compass. I would also point out that I don't think that this direction of study will serve to dismantle anything in our attempts to put down the relativists in their assertions about the isotropy of light's rate of propagation. In fact, I see the potential results as reinforcement of what we've already established regarding how to bend light using an electrostatic field in a classic cathode ray tube setup, which is what we're looking at here. In the top image, we can see two sets of parallel plates there, situated lastly along the path of the light beam going from left to right. And we're seeing one charged pair of those plates actively affecting the direction of the light's path. These two plates are functioning as a textbook capacitor. And we see the same geometry in the electrostatic gradient on the surface of the Earth. These two terrestrially measured forces are likely also just as affected by the celestially based influences cited in these same interferometric analyses. And in turn, I would like to see more experimentation, which inclusively takes sidereal, solar, as well as lunar influences into account in order to more properly shed light, pun intended, on this relation in the future. Thanks for listening, guys. That is the sum of the point that I'm trying to make here. And I welcome questions and comments right about now. Please hit me with them. I know it's a little hard to swallow after everything that this gang has been through for months and months and months. But that's where I sit with the empirical.
That's all good, man. And dude, thank you for that awesome analysis. You went much harder than I would have expected, man. Really
I don't pull any punches, Alan. This is science, right?
Actually,
not personal.
You didn't go hard enough from what I expected, so
I could. I pulled a few adjectives back a little bit, but the punches are still there. So, anybody want further clarification on any of that or explanation?
Yeah. So
Yeah, doctor, how are you doing?
So,
Stone, how are you?
Here, Bennett.
Very good. Yeah, make sure you cuddle up to your mic so we can hear everything that you're saying.
Got it right in front. How's that?
Yeah, that sounds good. Thanks.
Yeah, I wish that you were my defense lawyer, Stone. If I ever get accused of some criminal,
Oh, you can get away with anything with me on the squad. That's for sure.
because I don't think anyone.
We're losing you, doctor. You still there?
Oh, yeah, you're lagging out a little bit.
And if you were on the other side, I would just plead guilty because I don't think I had a chance. Yeah, let me check the connection.
Who wants to debate Stone? Someone step
Yeah,
up.
Yeah, it's pretty choppy there,
uh,
Doc.
yeah,
That's a little better now. Continue.
not me. Okay. Yeah, you brought up the meaning in Russian of imagination. Maybe it could mean, to Galiev, I think you were quoting, it could mean a model or a hypothesis. But you'll always have this problem when you're trying to translate from one language to another.
Indeed.
try
That's
to
why I
pin
felt the
down.
need to address that. Yeah, the language really is a hard barrier.
Yeah, so I think maybe hypothesis or model would also fit in some of the sentences that you quoted. I took some notes.
Excellent.
Yeah, the question of ether definition, that's always going to be a problem. From the time that Aristotle and the early Greeks proposed it as the quintessence, the fifth contribution to the material world. Ether can be understood philosophically. I think I pointed this out once as the source of all potential activations, which can produce all of the causes that we see in nature. Technical name for this is prime matter, and the theory that it's based on is called alomorphism. Prime matter says that there exists a source of all causes in nature, which itself has no material properties, but it is the cause of all things that we observe and can measure. Okay, and
How paradoxical.
well, it is something that must exist, because if it were nothing, it couldn't cause anything. But if you're going to attribute causes to something, according to the philosophy of realism, you have to attribute it to, in their mode of thinking, holomorphism, that there exists prime matter, which is, in some sense, what we're struggling to understand as ether. As you point out, ether is not material. However, if we think of ether as some of the models that have been proposed, which include the toroid model or the double toroid model for either light or for elementary particles, in either of those cases, matter is composed of ether flows, internal ether flows, in the form of a donut. Now, are you going to call those? Are you going to consider those a matter? And distinguish them from Æther when it's Æther that is being used as the model for the internal structure of light and of matter?
You actually said a lot of things there, and I'm feeling fairly congruent with your opening about the difference and what you said about prime matter, and that's why I brought up Eric Dollard early in the fight. That I totally am on board with his urge to the public to establish a difference between Æther and what he refers to as counter space, and he relies on the term counter space in description of light propagation. And I think he does it very effectively and sensibly, which is why I tend to adhere to it when we're talking about the difference between the two. Indeed.
Yeah, I think it's always going to be a struggle to understand Æther. Another example would be
just before you do, I want to deal with the comments you just made. You referred to toroidal geometry, and I see allowance for a coexistence, like I was pointing out towards the end, for two influences to be at play here with two different geometries. That when we look at some elements of EM force and what we were electrostatic force rather around the surface of the Earth, toroidal geometry seems to apply well in people's grip on mathematical explanation. As well, there is the magnetic component, which invokes a lot of dipolar geometry. And I see a combination of those, which is what I was pointing out towards the end, where those could actually be acting in tandem to produce the measurements that we're taking.
Well, are you aware of the primer model of Lassange, who shows
it does
that
ring a bell.
The galaxy structures that we observe, especially with the new telescopes, the Webb telescope, they can be understood as giant toroids seen from different directions and with different symmetries. And he points out that if this is true, and you adhere to the toroidal geometry of atomic structure, it says that there is a common structure that underlies from the smallest thing in the universe to the largest that we can observe, from the galaxies down to the atomic structures. All can be modeled with this toroids, or he uses half toroids, split in half. That always reminds me of I don't know if you saw the Physics Girl video, swimming pool, where what you see in the video underneath the water is just half of what's invisible above the water because it's in the air. You see the full toroid.
Entirely.
Anyway.
Well, I'm a little bit of a skeptic when we start to apply toroidal geometry on the micro scale and use terms like atomic structure. I think that lends adherence to the Rutherford Bohr model, and I see a lot of that in Atsukovsky's rationale, in the way that he puts his formulae together, and I'm just not on board with those particular intangibles, if you know what I mean.
Well, they certainly deserve a lot more study in order to either approve or disapprove of them.
No question there.
I would like to point out something to Alan. First of all, I am really astounded at the expertise that he shows in understanding and then presenting these new ideas, which of course he can't be getting from mainstream because they don't accept most of the things that he is presenting. I also have questions. I know that there is a repository, an archive for the documents in the Zotero location. A lot of videos have been produced. The Æther Roundtable, I don't know, you're in the 40s now. Are they also archived in Zotero, or can they be found somewhere else?
I archive everything. Well, they're on different websites too, because like everything we do is streamed to multiple platforms, but they're all backed up on my Telegram. Everything that we've ever done.
Yeah, the problem with Telegram is that I don't have a smartphone.
Oh shoot!
I would say that YouTube is a better source because you streamed them all to there, and they're all racked up by date. They're easy to find by title.
Okay. Is that true, Alan?
Yes, sir.
Okay. Yeah, I should have made notes when you were going through the start of the presentation. There was the presentation that you had a video clip of the what was it? The the Æther vector potential. Yeah, I had trouble understanding that guy. You're the only one who got it. All right. Yeah, Bennett sometimes seems confused, certainly to himself. No, I want to encourage you, and also want to make note that I've copied the Phipps book, first 440 pages, which includes the I'm struggling.
While you're thinking, I will inject yummy Phipps.
I can't wait.
Did I just witness that Cassander doped and pre-dunked on the toroidal model and Stone shut it down, or like what happened there?
Kinda. I'm not sure. It happened all kind of fast.
Well, I just want to make sure I witnessed.
It was a combination of the two, and instead of scoring a 3, it was like the one that's.
Well, what
like
I'm gonna let's see if we can keep the metaphor. I'm gonna
Okay, so it's the bottom of the 9th, and there's 2 runners on 3rd.
Yeah, let's bring it right to baseball. Perfect. Yeah. We should I'll just do visuals of the toroidal model, and then we'll talk about David LaPlante's particle / toroidal model, where things are both waves and particles simultaneously for him, but actually it's really just, toroidal fields or whatever.
Little baby toroides.
Right? He's like, how do you solve the double slit with particles? Well, particles aren't really particles. They're just toroidal fields with a base center and, say, a probability cloud. It's really close to how the current definition is, while still expanding over a giant and really functioning like a field, right? And then overlapping and interfering with itself the same way to give you the self-interfering particle photon that is really a field.
The only definition that they could use without the self-overlapping interaction. I mean, it's still empty either way because no one's ever seen wave-particle duality. Like, no one's ever seen the resultant wave function collapse where you see the particle pattern. So
No,
it's kind of
I
like
mean, if
kind
we're
of like
treating it
moot
as a
to be like,
toroidal field,
yeah, like you could say that, hypothetically. I
like you
guess,
could just saying, like, you could treat it as a toroidal field equally as you could treat it as a tiny infinitesimal particle that you can't locate but is inside a toroidal field, right? Because in either case, you're just dealing with the field, right? So it doesn't matter.
Right. Tomato, potato, as the Greeks used to say.
I think that's the quote. Yeah, verbatim.
Actually, I think it was
Did
tomato,
you-
ergo, potato.
That sounds right.
Oh, snap. I think that was.
Dude, I'm a sucker for the word images. I got a whole folder, so I might just throw a couple more.
Oh, I bet you do, Shane. I bet you got them plastered on your bedroom ceiling with little glow-in-the-dark paint stars all over them and stuff.
It's a virtual cam to no one that's on me right now that I can see on them. Actually has them all behind me.
One time I asked Dave to send me some toroids, and he sent me toroids for 72 hours straight.
Dave. Yeah.
And here's the thing, lads. It wasn't like an automated system where he's got like toroid folder.
No, and you
It
can
was like
tell him to
time
stop
intervals.
at number 2, and you're still getting number 74 all the way down. You're like, Dave,
Yep.
you made a mistake. Dave, you miscalculated. I don't care. Yeah, it ain't stopping, dude. I love Dave.
That's why we love him.
Some say
I love Dave.
some say he's still sending toroids to this day.
But actually, that was 2 accounts ago, and he's sending it to the wrong Shane, so we're fine.
So, any other impressions, questions, comments from the rest of this sizable audience we have here?
Yeah, I had a question. It was about you said the electric field gradient and whatnot, the magnetic gradient would facilitate like that periodicity in the measurement. So you're saying like as a substitute for like as an Ether mechanism, it would like the retardation in light would be caused, and the boost would be caused by that like the properties of that field interaction.
I'm seeing a composite set of influences here. The 2 terrestrial ones cited, like you said, the electrostatic, possibly toroidal geometry, superimposed against the magnetic dipolar geometry, the one you can pick up with your compass. And all of that, of course, being energy-based, I can easily see as influenced from above by the other celestial influences, the sun, the moon, etc., 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 to the rotation of the skyscape, however you want to think of it. Yes, that it could be a net computation of all of those influences to produce what is actually seen on the interferometer as you rotate it.
Well, thank you. That was my question.
So glad.
Why don't we call on other random bros to make them speak? Like, we'll just throw them a pre-done. Like, Xavier, what, you got a question, Xavier?
Thought I saw a hand up. We'll just start making up Twitter terms that don't apply to Discord. Yo, Eric, you had some hydrodynamic equations and stuff. Did you have anything you wanted to bring up?
Was that question for me?
That was Eric,
Which
actually.
No, it was just both of your presentations were very good. Stone makes some good points there that it's not settled. We have to investigate further. So I provided Alan with the references, the hydrodynamic references that Galev used. Of course, they're in Russian, but we found the page numbers. So I did anyway. Yeah, it's very good, but more study is required.
That's an understatement.
Xavier, did you want to chime in with something super intelligent and on point?
You better have a question, buddy.
No, that was a lot of info today. I just gotta gather my notes and try to make sense of this.
That's okay. I just wanted to put you on the spot. Thanks, man.
If all else fails, we
It's
can
all
start
great.
talking about two cyborgs with ping pong paddles.
Well, hey, in the end, I'm glad nobody wants to set me on fire. That's my end game right
Yeah,
there.
Stone,
Point
like-
scored.
Even if you disagree
Nah.
with all of us, you're still allowed to tell us to our face. Like, we're not gonna, we're
Yeah, I
gonna disown
don't-
you. We're gonna be like, fuck that guy. You
We've
know what? He
never-
didn't like what I said that day.
I think you misunderstand that we have like a personal affection to this. I mean, yeah, I guess in a way we do, but Not to any of the specifics, right? Like, I would never want to. I mean, even when I'm reading these things, I'm always loosely trying to grasp them myself. So I really appreciate it. I really, really, really appreciate it. I don't think we would expect. I think there's a very particular. I'm assuming there's a really particular reason Alan asked you to do that, and it's particularly so we can hear an alternative point of view. And we can go get the mainstream alternative point of view in a blink of an eye, as we all know. But to get it coming from a different side, a different point of view, that's invaluable. So thanks a ton, man.
Yeah, we respect your opinion,
So
even if you're
glad.
disagreeing with everything we say. You know what I mean?
Well, what you know is,
glad.
what you know that's different from the mainstream is that if there's a counter space interpretation to light propagation that's indispensable to it, Stone did his homework, right? And it's not going to be dishonest as in the mainstream. So yeah, I'm anxious to see his interpretation.
I like how he tried to seek
Thanks for the
common
advice, man.
ground, right? And he was like, listen, against the relativists, it's not you versus me, guys. It's you and me versus them. It was smooth.
Yeah, just stick that in there.
It's all good. You're not the enemy.
Excellent.
I mean, if you were the enemy, we would have already attacked you over that beef before with your atheism that couldn't be identified. Well, is it a background? Well, does it need it? Is it waving? Is it a background? No, we don't know. No, right? So it's fine. we should have known you had a different...
That's kind of what I geared up for. I'm ready for what you want to stand on. And we need to dismantle that and take a look at what you really are standing on and make sure you have the reasons you think you have for being confident on what you're standing on. You know what I mean? Ultimately, I'm just trying to be scientific about this. And when I look at papers like Galev's, and then I hear you guys drawing conclusions and then go, basically breaking Globy heads with it online, I'm like, hold on a second. Let's take a little closer look, because, there could be people like myself on the Globy side of the fence who are just going to summarize without taking any effort like I did to explain why, but they're just going to summarize. You guys just don't know what the hell you're talking about. And they will just hand wave dismiss you, and they'll feel right about doing it because they know why, but nobody else seems to. It doesn't add to their credibility any, but it makes the job tougher.
Well, wait. Is there a situation in which you see them not doing that and pulling that exact move, though? No matter how coherent we come across, no matter how correct on both fronts we appear, I feel that they're gonna hand wave and do the same reaction, regardless of the level of coherence or whatever.
Oh, quite.
Yeah.
Oh, quite. Most of them just don't think you're worth the time to explain it to you. And that's,
I think
to
Stone's
their own
point,
detriment, right?
I mean, Stone's point, I think, is that we don't want to use that as an excuse, right? Because we would want someone that's going to be, have a more elevated, nuanced take on this to, respect our. We want to treat the topic with the proper respect, I guess, is maybe the best way to put it.
The two adjectives that come to my mind are articulate and founded. If we could find some Globies who've got that, we would have somebody to talk to. That would be optimal.
Well, let's see if Alan can bring that out of Mord 1, the best candidate so far.
Oh, God, don't touch that guy with a dead stick.
Oh, no, it's already set up, I think. Right, Alan, maybe?
Yep, 24th, 8 p.m. Eastern, we're going to be debating quantum mechanics.
Nice.
No kidding.
Let's see if we can get a Globy to admit to any of that on anybody. But as far as our differences, that comes down to, I think, does light need a medium? And I think we still think yes, and you think no. Does sum up our positions?
Yeah. What it needs is counter space. It needs a modality through which induction can be initiated and then propagated. And I see a direct relationship between space and counter space in so many contexts of electromechanics. It just can't be ignored in this context either.
Right. So that reminds me, actually, Alan did some math on the field and how it's represented. He actually played a wonderful clip of Bennett that I have to go rewatch. So our friend Cassandra here going over what the curl means in that specific Maxwell equation. But we should also do, I think, next week, history and theory of electricity. So that's gonna, I think, tie in nicely to it. But man, I forgot what I was gonna say. I had a different point.
Bitchin' regardless.
Oh yeah, about Dollard. Since Dollard is like the source of the counter space proposition, do you know any old textbooks in PDF format that I can get my hands on between now and then?
If only. He talks about
Man.
Townsend Brown, and there are he's got a few heroes. And for Dollard, I think there's more fruit in the video lectures that they've put together, even all the way back to the 90s.
Yep.
When they were in Oregon or Washington or wherever they were, the three of them.
Yeah, okay.
With Brown and Lindemann, those guys. They had their yellow T-shirt club. That was really fucking awesome. But no, excellent information even back then to choose from.
So I found exactly 3 old presentations on YouTube, and you're telling me that is the sum total collection of Dollard that's available to me? Okay, great.
Well, there could be more than 3, but,
you said 3.
I think it could still keep the total under what you got on both hands. So yes, somewhat to that effect. Yeah.
I mean, they're all like 2 to 3 hours, right? So they're beefy, but.
Oh yeah, they are substantial. Make no mistake there. Yeah.
Nice. So that's pretty much what I'm basing my presentation on, those videos entirely though. So that's cool. I thought there was some other reading I could do. I found some PDFs, but I figured there might be some more. Oh, I think Cyrus
I got
has
a couple
Yeah,
books.
I think we have some.
I think
Well, in any case.
Yeah. Here, do you want any of these?
Yeah, anything Dollard related or electrical field math related, send to strangers.
Sure.
Get those to you after we wrap up here.
Oh, are those publications or videos? What are we looking at with those 8 entries?
Those are PDFs written by Dollard.
Oh, excellent. Okay, yeah, I think I have those in my little folder too. Yeah, cool, man.
Nice.
It's like instead of trading Pokemon cards and stuff, like, I got that new Charizard. Like, bro, do you have a 1991 Eric Dollard Theory of Wireless Power?
Like, that's priceless. Ooh, can I
back when he was playing third base for RCA, yeah.
Yep. All right.
Any other questions?
Cass, are you back yet? Were you able to get that sorted? Doesn't sound like he was. Oh, Cass.
Yeah, is the good doctor there? He looks like he's there. Maybe not.
Oh, before we wrap up, I was going to ask Lily. Lily, you seem to be glowing, and I wanted to ask how you got your glow.
Oh, hi. Oh, well, thank you for the glow. It's all, brushtail coffee glow, but I had a really lovely testimonial in case you guys were interested. Yeah.
Always.
Oh yeah. So as you folks might know, I was born in Pripyat, and in case you don't know, that's in Ukraine, and it's where the Chernobyl disaster happened. And in fact, I was actually born on exactly that day, just minutes after.
Oh no.
Yeah, just minutes after the disaster happened. Anyway, long story short, can you guys hear me okay?
Yeah,
absolutely. Loud and clear.
Very
loud
well.
and clear.
Oh, anyways, long story short, of course it had an effect on me because, imagine being born right there on that day when that happened. So I had this little lump on my forehead, and turned out it turned into an absolute fully, matured, fully formed third eye. Yeah, I know. So my poor mom, she had to hide it with bangs and everything. I don't know if you guys have seen some Simpsons, episodes where they had fish in that Mr. Burns's nuclear power plant.
Yeah, the
where
three-eyed
we're-
fish in the lake.
Yeah.
Are
with
are you a
President
bowl cut refugee?
Huh? Yeah, well, okay, let me just quickly tell you the testimonial. So I had this third eye, and my poor parents, they were poor, they couldn't really leave the area, and so, that's why that happened. Anyway, long story short, some good friends of ours, they suggested we move to India because Lord Shiva has a third eye, and maybe, they would be more accepting, we could make a living. So we did. And then we made a living there in India, and then we migrated legally to the United States, and this is why I'm here. Long story short, I had this third eye, and then I started drinking brushtail coffee, and then that third eye just started shrinking and shrinking and shrinking, and now I have a nice, clean, glowing, smooth forehead. So
Wow.
brushtail coffee is amazing, folks, and it's so tasty too. So even if you don't have a third eye, the taste is the reason to drink it.
So you're telling me that when you were born, you were subjected to an alteration in your DNA due to radioactive waste material from a power plant, and that caused you to develop what's known as a third ocular. And your parents, trying to hide your abnormality, had to flee the country and legally migrate to America, where you started drinking brushtail coffee, and suddenly the third eye abnormality removed itself from you, and you've been cured. So, in other words, you're saying that brushtail corrected the flaws in your DNA
Allegedly.
structure caused by radioactive material.
Yes, allegedly. Let's not
Allegedly
forget.
corrected our DNA. That's a much better clarification. Thank you, Toby.
Wow.
Thank you. You
Wow. So you're
lads are
saying
so much more articulate than I am. I'm just in awe. Thank you so much for rephrasing everything, Alan G. I love it.
I just couldn't believe the astonishing connection, because I don't know if you knew this, Lily, but I used to have webbed feet and webbed hands.
Oh my god.
Like, have you ever seen Batman
have a
and the
guap
Penguin
hole.
and all that?
Used to pop out your chest.
Yeah,
I
like
saw
he-
Aquaman.
yeah, yeah, dude. Have you seen the Little Mermaid? My lower half of my body used to be a literal fish.
You're gonna say you were a
And
crab.
then I started drinking brushtail coffee. Actually, I don't drink the coffee. I bathe in it, and I started developing bipedal legs.
Oh yeah, that's not all that different from the story when I told you I had those size 11 and a half big feet, remember? My friends used to tell me I don't even need fins for swimming because I could even walk on water. They were so huge.
Wow. They gave you a buoyant force. That's crazy. But yeah, so if anyone's looking to get life-altering coffee to save you, allegedly, head over to brushtail.coffee. My boy Toby makes it homemade with his grill when you order it. Imagine getting coffee without an expiration date on it. You get it with a roasted date signed by my boy.
That's right. Yo, thanks guys. And appreciate the the feedback. I'm gonna have to just keep roasting away, getting rid of all these web feet and third eyes. Allegedly.
Should try cancer next, right? That'll be the next one. Or
Oh, good.
Well, you know what's crazy, Toby? You know how they pour industrial waste into like rivers and stuff? 'Cause it's just cheaper. If you started pouring your coffee into it, do you think that it would counteract the industrial sludge and make it like healthy again? Like I think I've heard that it restores vitality to nature in all aspects.
Well,
I think you might null out some of the Prozac at least.
Remember all those projections about the rising sea levels and how we were supposed to be hitting the exponential curve of the moisture due to moisture rates, the greenhouse effect? Well, let's just say that maybe, possibly, who knows? Maybe there's some carbon capture occurring with some special vats of brushtail coffee. Who knows?
Dude, I knew you'd find a way to inject climate science into it successfully.
So all their projections
and you didn't even have to use a graph.
all their projections were wrong because maybe because of brush tail coffee. Who knows? But yeah, anyways, everybody, thanks for listening in. Was there anything else?
Well, I think that was it, man. But yeah, 52 episodes. Do one more, and we're at a full year, I think, because I'm off canon by
I was
one.
gonna say, did you guys sync up cannons and now it's on the same, or did you
Yeah,
just
I think
decide
we
you
are
don't care?
synced
Nope.
up. Oh,
Oh,
I-
we're
snap,
one
dude!
off.
If we're synced, then yeah, we're one off. But
Oh, gee.
next week will be our 100 or our 100th. Will be our 1 year anniversary of Prezzies.
Crazy.
Wow.
Every week consecutively for a year.
I
Seems
I
like
just
only
wanna-
yesterday.
Sorry, I just wanted to say that you teachers are awesome. I'm in just awe of you guys, just so articulate, so knowledgeable, and so humble, willing to share your knowledge with us. So patient. So I just wanted to say a very special thank you to all of you.
Well, thank you, Lily.
Lily, what did you learn?
Well, I mean, I learned a lot. I'm soaking it in. I'm still digesting it, so don't ask me to regurgitate it yet.
Okay, on Friday night we'll have a test then.
We should do quizzes.
Yes, we will be doing a quiz next week.
Like
Oh
that.
God, you guys are strict too.
Progress reports.
Yeah, we're gonna go ahead and wrap
Just
it
wanted
up
to,
here.
sorry.
Oh,
I was just going
you're
to
good.
throw
Real
in
quick,
there that I'm pretty sure when I started looking into the flat Earth, it was actually a globe. But at that time, Toby just started adding his brushtail coffee to the water to fix the environment, and it went flat.
I love how it's a
Wow.
community effort now to troll. I love it.
All right, Stone, I wanted to say thank you for your analysis and your presentation your follow through and commitment to, teaching us what we don't know, and putting, and actually critiquing it in a meaningful way, man. It's like I said, Lord knows the opposition can't provide any substance for help. So,
It is my
it's
absolute
great to fall back on you.
It is my absolute pleasure. I'm so glad we could have this little chat.
All right, guys, we'll be back on Thursday for research and reading night. And then Friday will be Flat Earth Friday, episode 113, the big 113, boys. And after that, Tuesday, Shane will be doing the history of electricity, and we'll be getting into a little Eric Ballard.
Hoo-ha.
Awesome. Well, take care, everybody. Much love.